play along with. So as we go along, all good. Cool. So before I get too far, has anyone ever heard of Desmos before? Show of hands if you've heard of it. No? Cool, I won't ask if you've used it then. Presumably you would not used it if you haven't heard of it. So today I'm going to talk a little bit about Desmos, what it is, why you could use it, and how you could use it. So if you've got an internet connected device, whether it's a phone or tablet or PC, whatever, you get to play along. I just want to show you 3 quick activities that it's got built into the website that's all free and it's all pretty easy to get into. So first of all, what is Desmos? Essentially, oh that's not looking too good. Alright, it's a graphing website that, okay, there's a little video there that doesn't work very well. It's a graphing website that you can just type in whatever function you want to write and it'll draw it and it looks generally really good. I think that's going to be problematic because most of them has little videos like that in it. So, essentially what they can do, you can write your graph and change the colour of the line, make the line curvy, make it finish points, start at points, and a whole bunch of people have gone and created all sorts of interesting things. Some of it being things like following the orbit of the moon around the sun, or following, sorry, the moon around the Earth and the Earth around the sun, so there's a relationship there, or just going and draw their favourite Pokemon. So I think that it's really good because it's got this low cognitive load. All they need to do is write a couple of things and it starts producing fun faces. And what they're really doing is fairly complicated maths behind it. So they're doing all the graph and calculator stuff, but they don't need to go get their sort of class pad or their big angry device. They can just start doing this straight on a website. It's pretty attractive and seems to naturally differentiate. The kids who want to go further can go and research more. The kids who just want to do what they're getting told, they can just follow that. And best of all, there's some classroom prepared activities, which makes our lives pretty easy. So if you went to Desmos.com, you'd come to a page that looks like this. Your first inclination will be go click on that big red button, and you would be shown something that looks like that. That's what that video is meant to look like. And you've got some, you can start writing your functions and all that sort of stuff if you're into that level. But what we'll do is we'll go ignore that big red button, and we'll go to the little green one here that says, are you a maths teacher? And you go to this page. Now, a whole bunch of math teachers have already gone and created all these activities that the kids will be able to jump straight into, and these are the ones that I'm saying are low cognitive load. So today I wanted to, if I keep up my time, I'm a little bit behind, that's okay, talk through Central Park, which is a fun one. It's really good for a wide range of audience. Polygraph, which is a bit about having kids learning vocabulary when they're dealing with maths. And Marble Slide, which really takes them into some fairly advanced maths. So we'll see how we go with that one. So these little Central Park, Polygraph, and Marble Line. Students go to student.desmos.com and they'll type in, you put up on the board or whatever, we're going to put these 4 digits in, and it goes, welcome to Central Park. What's your name? Type in their name. They don't have to register, they just have to put a name in, and it'll say this. So you need to drag these 3 dividers across. Most kids think they can do that, there's no numbers, you haven't got a page full of questions 1 through to 15. All they have to do, pick up and drag them across. So they drag them across, and then a car tries to park. And the car tries to park. There's not enough room, so they have to adjust it a little bit. Car tries to park again, not enough room, they've moved it around. Eventually, they've sorted it all out, and the car's fit. Awesome. What happens next? Different sort of car park, same concept. So they're moving along, can they fit them? Again, I have to fiddle a bit left, a little bit right. Another car park, what's going on here? Fiddle left, right. Kid ends up saying, sir, wouldn't it just be easier if you told us like the measurements? And they say, well, what do you want to measure? So that's really getting them to think, oh, actually, I need to be measuring something here. So you give them a couple of numbers. Now you've got the numbers, now what are you going to do? So at the top there, they just have to type in the number. They can figure it out themselves, or they can enter the whole equation there, and it will automatically figure out the number for them. What if it's not 35? What if it's 48 or 24? This is where it starts introducing the algebra, so it's already sort of getting them to go, oh, I can change lines around. Now it's giving me the power to sort of abstract this into just saying, well, it doesn't matter the 35, it's just W, whatever the number is. It's just going to make it simple. So, what do you see as a teacher? Your kids are out there playing with this. You can see all the screens that they're going to see. And on that side, you can see all their names. Caution, some kids use names that aren't their own, but anyway. You can see how far they're through the activity, if they've skipped over any screens, and if they've made any errors. The system sort of says, oh, it's actually 8, they might have tried to do 7, or the cars didn't fit. So you can actually see where they're up to. And a lot of these will actually ask them a question, and they have to type in what their answer would be for them to be thinking about it. And if you click into one of those questions, you can then go, oh, well, what did each of my students write for this question? So different students obviously had slightly different approach. And I can see that Grace has still not quite got the answer there. So it's able to then wander over to Grace and say, oh, can you understand what you have or haven't done? And work it through. So I think Central Park is a really cool activity for upper primary, lower secondary, possibly even middle primary, depends how they're going with it. It's a great transition that starts getting them thinking about arithmetic and then even into algebra. And I encourage the kids to take some time to think rather than just guess and check. The guess and check students, you can usually see them sort of 1, no, 2, no, 3, no, 4. Oh, yeah, they got it. So if they're actually stopping and thinking, they'll learn more about it. Next little game, it's called Polygraph. So hopefully you're already thinking, it's got the word graph in it, so it must have something to do with graphs maybe. Polygraphs, are they going to lie? The way it works basically is a game of guess who. So there's 4x4 grid, and the kids identify by yes and no questions which one they do or don't want. So that's all pretty straightforward. And they go, okay, well, no, he doesn't have long hair. Finally, they get rid of the ones that are not there. They get to the one that must be him by system of elimination. But then we're going to change it up. And rather than have faces, we've got shapes or graphs or pretty much anything that you can put up there. And now the question starts being, well, how do you differentiate between two different shapes? So yeah, DJ Huckleberry Spin over there, he's decided that he's asking, is it blue? Well, does that matter? He's wasting questions on that. And Hayang is saying, no, it's not blue, stop being silly. They get to some of these other questions, and you can see that they need to start asking, are they obtuse angles, are they acute angles, a little bit more precise in their vocabulary. This could be just, is it a triangle, has it got 4 sides, has it got 3 sides, these sorts of things. Obviously these are all quadrilaterals, but you can change those 4x4 grid to be anything you want along the way. Nearly there. Cool. So 16 images can be changed to different things. One hint is to give the kids a reward for being the most correct or the best questions, just to encourage them to actually want to write the right questions, and otherwise they start getting into chat. The system actually automatically rearranges who they ask. They're not going to be in the same pair, and they're not going to be working with the person next to them, then they can just sort of see who they've picked. Last one, personal favourite, doesn't work on phones, but if you're on another device, essentially, oh, okay, now this is going to be videos again. All right, what the system is there's a little purple ball and a whole bunch of stars. Let's see if the next button works better. Okay, purple ball, a whole bunch of stars, and they draw lines, and the purple ball will follow the line and pick up the stars. So at first point, they just draw a line, and the ball collects the stars. The second time, they might want a couple of lines, so they collect stars from different points. And over time, they actually can be doing very advanced trigonometric, whatever, any derivatives, any of those things, because the graphing calculator under it is powerful enough to collect all of those different functions. And as a teacher, you can sit there and watch how they're doing, select one of those, and see that different kids are actually trying different sorts of graphs to try and collect all the stars. And my warning is that game is so addictive that the kids usually don't want to go to lunch or whatever, they just want to get those last couple of stars. So I think it's a great little activity. If you get a chance to have a look at, you just have to go to desmos.com and enjoy. Thank you very much.